ઇન્ટ્રોડક્ટરી ક્લાસ હોય છે.
Okay. স্লাইড দেখা যাচ্ছে তো সবার?
Yes, sir.
Okay. In my part, we'll discuss about the different scheme, that is controlled and uncontrolled converter. In case of controlled and uncontrolled converter, uncontrolled converter is basically the combinations of the different circuit consist of the diode, and controlled converter is basically the device which is basically the combinations of silicon controlled rectifier. So this is the diagram which are present in this slide. That is, if you see, that is basically called a well-known scheme, that is single phase half wave rectification scheme. So in a single phase first wave rectification scheme, what are the components required for that? This is a AC source. This one is the AC source, and this is the transformer. And transformer output, the diodes basically connected. Okay, in transformer output. But here, one thing I want to mention here, that there will be no such difference between that electronics diode and power electronics diode from the operating point of view. But in this case, power electronics diodes is basically designed for higher voltage and higher current rating. Okay, so this is the only difference. In electronics, diode may be operated for 10 volt, 5 volt, like that. But here, diode, this is the power diode, which voltage rating and current rating is very high. Now, you see how this diode operates. For the operation of the diode, all of you know diode are basically two-terminal diode. That is, one terminal is called anode, and this is the cathode. When anode respect to cathode is positive, during this condition diode will be in forward bias mode, or you can say diode is on. So anything, anode potential should be higher than the cathode potential. It may be cathode potential minus say 2 volt. If anode potential is say 0 volt, then this diode will be in forward bias. Okay. So for positive half cycle, you know that alternating wave is basically, in case of, if you consider, sorry, this is the alternative wave. In positive half, that anode is basically positive with respect to cathode. Okay, but every diode have certain threshold voltage, and after that this threshold voltage generally what will happen, when the anode voltage is more than the threshold voltage, then with respect to cathode, then we can say that diode is in forward bias condition. Okay, so for positive half cycle, diode is in forward bias, and if you neglect the threshold voltage, so we can say diode is basically operating from say 0 to pi in this region. So this is basically written here. Diode is basically conducting from W to 0 degree to pi degree. And in this condition, if you neglect that any drop here, that is the voltage drop. So after diode is in forward bias, it will be act as a short circuited current. So if there is no such voltage drop in diode as well as in transformer winding, so we can say in this condition, output voltage is equals to, that is the supply voltage or voltage across the secondary side. So this is written here, V0 is equals to Vs. If you neglect the threshold voltage drop of diode or neglect that voltage drop across the inductor, across the impedance of the transformer winding. And if you know the output voltage, so automatically you can able to calculate what is the current flowing through this load. And here we consider that load as a resistive load. So current is basically, you can get that I0 is equals to V0 by R. Okay. So I0 is equals to V0 is R. But omega t is equals to pi. In these conditions, output voltage is 0 and current also 0. Okay, because current is basically follows the output voltage. In negative half cycle, what will happen? In negative half cycle, anode respect to cathode is lower potential. So diode will be remains off in this negative half cycle. So we can consider that path as a open circuited path during negative half condition. Okay. So in this condition, that condition is basically called diode is in off state or diode is in reverse bias, and that is also called the blocking state also. And this zone is basically stay from omega t equals to pi to omega t equals to 2 pi. In this condition, output voltage is 0. So if the output voltage is 0, automatically that load current is 0. Okay. And after omega t equals to 2 pi, means after this, again that positive half is coming here. That positive half is coming. So again that diode will be in forward bias. Okay. Now বলো তোমরা যে এটা বোঝা গেল কেন, whether it is clear to all of you that operation of diode half-wave rectification scheme. বোঝা গেল কিনা? কারণ যদি কোনো অসুবিধা থাকে বলতে পারো। তাহলে ধরে নিচ্ছি বোঝা গেছে, তাই তো? এইবার হচ্ছে যে আমাদের এইটা হচ্ছে যে তোমাদের প্রচুর প্র্যাকটিস করতে হবে ফর ডিফারেন্ট স্কিম। হোয়াট ইজ দ্য ইনপুট ভোল্টেজ ওয়েভফর্ম? Means you have to draw this different voltage current waveform either in graph paper or in proper scale. Okay, this is my suggestion. Frequently means you have to practice. That is these waveforms are very much important from not only that for finding that output voltage, output current expressions, but if you draw the properly that what is input voltage, what is output voltage, what is output current, etc., and what is the voltage across that. So the concept is clear in this condition. So if you correctly draw this diagram, so my suggestions you have to frequently draw this diagram either in graph paper, because graph paper you need not to draw or you need not require any scale. But if you want to draw this diagram in plain white paper, so for that during that time you have to definitely use that scale. Okay. So here first one is the source voltage, that is the alternating sinusoidal voltage. And what is the output voltage? When positive half will get output in positive half and it directly follows the input, but in negative half the diode is in reverse bias, means this path is open, so there will be no such voltage is there in output, so that part is 0. And again when again that positive wave, positive half comes, then again you will be get output voltage. So this is from this diagram you can easily say, without see the proper circuit, you can comment that this scheme is basically the half wave rectification scheme. Rectification means alternating current is converted to direct current. Okay, so this is the waveform of the half wave rectification output voltage. And I0 is basically already in previous slide we see I0 is equals to basically V0 by R. So in this condition, in these conditions, that is the current is basically follows the exactly follows the voltage waveform, except that magnitude is different. Okay, so this is basically the output current. And similarly, you can say that is also the current supplied from the secondary side of the transformer also. Okay. And now, if I want to draw the voltage across the diode, so in positive half or forward bias condition, diode is in forward bias conditions, mean you have to consider that part as is short circuited path. So in these conditions, what is the voltage across the diode? Voltage across the diode is 0. So that is why that in positive half, that is the voltage across the diode is 0. But negative half, what will happen in negative half? That is the supply voltage is basically negative half. That you can consider that path as open circuited path. Here, this part is open circuited path, and whatever the voltage across this terminal, so this is minus plus, so this is basically the voltage across the diode in negative half. Okay, so in that way you have to draw the different voltage current waveform. I think for half wave rectification is a very simple scheme, and you have no confusion to draw this different waveform. You have any confusion? Because frequently you have to draw this voltage waveform, input voltage waveform, output voltage waveform, output current, voltage across the diode, like that. বুঝা গেছে? কি হলো? আছো না নেই?
Yes, sir.
বুঝা গেছে কি?
Yes, sir.
একটু মাঝে মাঝে রেসপন্ড করবে, তাহলে তোমরা আছো কিনা বোঝা যাচ্ছে না।
না না স্যার, আমরা সবাই থাকি মোটামুটি।
আচ্ছা, ঠিক আছে, না সুবিধা অসুবিধা হলে একটু রেসপন্ড কর।
Okay, sir.
Okay, now you have to find out that what is the average output voltage, what is the RMS output voltage, what is the average output current, and what is the RMS output current. Okay, so for finding that average output voltage, that is V average of output voltage, so we have to either you have knowledge about how to find out that average voltage and RMS voltage from the waveform. So it is very much simple for this waveform. That is, you have to consider that whole cycle here 1/2 pi, and you can conclude that as a 0 to 2i pi Vm sin omega t d omega t also, but only in positive half you will be get 0 to pi in this region. So suppose if this is the waveform, that is in 0 to pi region, only that output voltage are present. That is also in this region, you see that is 0 to pi region output voltage is there, and pi to twice pi 0. So if you take integrations from 0 to twice pi, and if you consider that whole cycle, so from pi to twice pi, that voltage is 0. So that is why here the integrations from 1/2 pi 0 to 2 pi, that is for average voltage 1/2 pi 0 to 2 by Vm sine omega t d omega t. This is very simple integrations, and after integrations you have to put that value of integrations, that is limit 0 to pi, and ultimately you will be get that Vm by pi. So this is the simple integrations. Either you have to remember or you have to practice that what is the integration of sine omega t, what is the integration of sine square omega t, what is the integration of cos omega t, like that. Similarly, for that similar type of waveform, if you want to find out RMS voltage, V0 RMS, the RMS output voltage. So this is the standard formula, that is root 1 by 2 pi 0 to pi Vm sine omega t square d omega t, and this is basically after integrating sine omega t square, that is 1 by 2 sine square omega t 1 minus cos 2 omega t, and after that you have to integrate with respect to d omega t. So ultimately you will be get that output voltage, RMS output voltage is Vm by 2. And after getting that average output voltage and RMS output voltage, it is easier to find out the average current and RMS output current, because here now we consider only resistive load. So exactly that current waveform is basically follows the voltage waveform, only the difference is in magnitude. That is V0 average by R, this is basically the magnitude of the current, and V0 RMS by R, this is the magnitude of the RMS current. Okay. Now another thing, for designing of this type of circuit, you have to know what is the peak inverse voltage. Peak inverse voltage means that is the voltage across the diode in reverse bias condition. So if you observe that diode waveform, that is the last one. So voltage across the diode maximum is basically equals to the maximum value of the supply voltage. So this is basically the peak inverse voltage of the diode. Okay. And that is also written here. You see, peak inverse voltage is the maximum voltage that appears across the device during its blocking state or reverse bias conditions. Now, sometimes also people wanted to know what is the power delivered. Power delivered is very simple. Power delivered is basically product of voltage and current, all of you know. And here you have to consider that RMS output voltage and RMS output current. So RMS output voltage is Vm by 2. So this is Vm by 2, and this is also Vm by, sorry, this is also what? This is also Vm by 2 into R. Okay. So in that, that is the Vm square by 4R. So based on this output voltage, output current, average output voltage, average output current, RMS output voltage, RMS output current, you have to derive so many things. So now you see, sometimes we have to find out what is input power factor. So that input power factor is basically the ratio of output power divided by the supplied power. Ratio of output power divided by the supplied power. Output power is basically V0 RMS into I0 RMS here. Okay. And what is the input power? Input power is basically the supply voltage is Vs, because supply voltage is remains always present during the whole cycle, but output current or the supply current is basically equals to 0. Okay, so in that way you have to find out that input power factor. So input power factor is equals to, now if you replace all the value V0 RMS by Vm by 2, I0, sorry, the V0 RMS is Vm by 2, I0 RMS is Vm by 2R, and Vs, you have to replace that Vs, that is the Vm by root 2, and I0 RMS is basically the Vm by 2R. So input power factor for this combinations you will get, that is 1 by, because you have to replace that as a Vm by 2, this is Vm by 2R, and this is again Vm by 2R, and but these things is different, that is the supplied voltage, RMS value of the supplied voltage. If you know, all of you know, if Vm is the maximum value of the any voltage, so supply voltage should be Vm by root 2. After replacing all these things, ultimately you will get that input power factor is 0.707. This is the lagging power factor. Now you have to find out that ripple voltage. Ripple voltage means this is if you observe this output voltage waveform. So this output voltage waveform not a flat DC, some ripple is there. So you have to find out that what is the ripple voltage, and standard definition of ripple voltage is that is root over RMS output voltage square minus DC output voltage, or you can say that is average output voltage square. So RMS output voltage square is basically Vm by 2 square, and average output voltage is Vm by pi square. And after taking root, ultimately you'll be get that ripple voltage is 0.3856 Vm, or you can say 38% of the total voltage. Now, after getting that ripple voltage, you have to find out the ripple factor. This is the standard definitions you have to remember, and will not give any hints about that. Sometimes that in numerical problem, we have to find out in some of the problem what is the ripple voltage factor, what is the ripple voltage, what is the input power factor, because only the known parameter in your hand is output voltage, average output voltage, and RMS output voltage, and average output current and RMS output current. So you have to practice more so that you can remember this equation, that is the, or you can say that formula. Ripple voltage factor is basically that ripple voltage by DC output voltage, or you can say average output voltage. Okay, so that is VR is equals to 0.3856 Vm, and DC output voltage is Vm by pi. So this is basically 1.211. This is the ripple voltage factor, and that is basically by constant for this type of half-wave rectification scheme. Now you have to find out rectification efficiency. Rectification is basically the DC output voltage by AC input, DC output power by AC input power. So DC output power is DC output voltage into DC output current, and AC power is output voltage into output current. So here just you replace Vm by pi, Vm by r pi, Vm by 2, Vm by 2r into 100. So that is basically the 40%. So half-wave rectification scheme, rectification efficiency is very poor in the range of 40.53%. Whatever the and another two factors are also there, that is called the transutilization factor. This is applicable for the in case of the transformer utilization factor, or that TUF. So that is basically determines how the transformer is utilized for this purpose. That is that output voltage of the transformer utilized for this purpose. So transformer utilization factor is basically the ratio of PDC divided by RMS AC input voltage into RMS AC input current. So PDC is very simple, Vm by pi into Vm by r pi, and RMS AC input voltage is basically Vm by root 2, and RMS AC input current is Vm by 2r. So transutilization factor is only 0.2865 or 28.65%. So rectification efficiency and transutilization factor is very much poor in case of half-wave rectification scheme. And another factor also we wanted to know from you, that is the case factor. Case factor, what is the definition of case factor? Case factor is very simple. All of you know from the basic electrical engineering point of view, all of you know this definition. That is the peak value of the source current divided by the RMS value of the source current. Peak value of the source current is basically Im, and RMS value of the source current is basically Im by 2. So that ratio is case factor is 2. So whatever the relations we discuss here, all are based on these 4 parameters. That is the output, average output voltage, RMS output voltage, and average output current, and RMS output current. Okay. Any doubt up to this discussion? কোনো ডাউট থাকলে বলো এই অবধি।
Yes, sir.
Okay. Now we will move on to single phase half-wave rectification scheme, considering that inductive load. Okay. So in case of inductive load, when the switch is on, that positive voltage in positive voltage applied across the diode, and diode will be in forward bias when the anode respect to cathode is positive, So in this case, you will see this is the output voltage, and here we consider that inductive load that L will be very high. So due to that region, when the current flowing through the inductance, some current is flowing through the inductance, so that inductance, this is the nature of the inductance. Inductance is to maintain that current. If the inductance value is more, so you will see in this case that is the inductive current I0. So I0 is basically equals to 2 Vm by omega L. So this is the maximum value of the, and if you observe, and all of you know, in case of inductance, current is slightly lags the voltage. So here this is the output voltage, and when output voltage achieve peak, and if you observe that output current, so output current achieve peak after attaining that peak value of the output voltage. So we can say this is the inductive circuit, and this is the property or characteristics of the inductive circuit, that inductive in case of inductive circuit, always that current lags the output, lags the respective voltage by certain angle. Now here you see how will we get that current expression, that is what is the how we will get that maximum value of the current is twice Vm by omega L. So that is basically obtained from next slide. If you see output voltage, generally voltage across the, if you measure the voltage across the inductance, so that voltage is all of you know, that is the formula for applicable for that inductance. That is voltage across the inductance is basically we'll get that information by using this equation L di by dt. So for this output voltage, this is L di 0 by dt, and that voltage should be equals to Vs, because there is no other component is there, and Vs is basically equals to Vm sin omega t. So now if you take integrations in both the side, so ultimately you'll be get that expressions I0 is equals to Vm by L sin omega t dt, or after taking integrations you can write that is output current is equals to Vm by omega L cos omega t plus C. Now when t is equals to 0, during that time is I0 is equals to 0, so C is equals to Vm by omega L. So after putting that constant in this equation, so ultimately you'll be get that equations of the output current. That equation is Vm by omega L 1 minus cos omega t. Okay, so this is basically the expressions which is basically controls the output current waveform. And here if you put that value, when cos omega t is equals to 90, during that time you'll be get in this here, when the cos omega t is equals to pi, during that time, from these expressions, if you put that value cos omega t is pi, so that value is basically provides that cos omega t value is minus of 1. So minus of 1 and minus of this is plus 1. So ultimately that maximum value of the output current is twice Vm by omega A. Okay. So in this way it will get, and why we follows we write that V0 is equals to Vs, because when the switch is closed, that entire supply voltage is basically supplied to the inductance. So that is why that output voltage and input voltage, they are basically following that same nature. And if our voltage waveform is equals to Vm sin omega t, so for that case, if you find out average voltage, so average voltage is equals to 0. I0 max is basically of we'll find out that is 2 Vm by omega L, and I0 average is basically 1 by 2 pi 0 to 2 pi Vm by omega L cos 1 minus cos omega t d omega. So this is basically the equations of the I average. So similarly, you have to find out what is IRMS. That is the same expressions you have to use. 1 by 2 pi 0 to 2 pi. This is the expressions of the current, that square into d omega t. And after taking integrations, you have to put the limit. So ultimately, you'll be get that I0 RMS either in terms of voltage, that is root 3 by 2 Vm by omega L, or root 3 by I0 average. Okay. So this is basically the entire mathematical calculations related with inductive load. If you have any confusion related to with this inductive load নিয়ে কারোর কোনো কনফিউশন থাকলে বলতে পারো। ওয়েবফর্ম গুলো বিশেষ করে ভাইটাল ওয়েবফর্ম গুলো যদি প্রপারলি আঁকতে পারো, obviously এখানে ওয়েবফর্ম কারেন্ট ওয়েবফর্ম you can able to draw after getting the expressions of the output current. এই বোঝা যাচ্ছে?
হ্যাঁ স্যার।
বলছি যে তোমাদের কতজন আছে গো? মানে এখন কতজন নয়, টোটাল কতজন?
12 জন স্যার।
12 জন, তাই তো? আচ্ছা, ঠিক আছে। এবার হচ্ছে যে আমরা ক্যাপাসিটিভ লোডের ক্ষেত্রে মানে সিঙ্গেল ফেজ হাফ ওয়েভ রেকটিফিকেশন স্কিম বাই কনসিডারিং capacitance as a load. Okay, so the supply voltage is same for every case. So this is basically the supply voltage, sinusoidal voltage. Now, what is the output voltage? That output voltage is basically voltage across the capacitance. So initially voltage across the capacitance is 0 because in initial condition capacitance will be act as a short circuited path. So initially that value is equals to 0 and gradually that capacitor is charged, and after getting that capacitance charged at maximum voltage, so in this voltage now it retains its value to the entire period. Okay, if you neglect that loss in capacitance. So this is basically the output voltage. V0 is equals to Vc. Now you'll see I0. What is the output current? Mind that this output current is basically current flowing through the capacitive load. When the capacitance in initial conditions, that current flowing through the capacitance is maximum because capacitance is short circuited condition. But after charging at maximum voltage, now this capacitance will be act as an open circuited path. So due to that reason, in these conditions, that current across the capacitor or current flowing through the capacitor is equals to 0. So this is basically the standard waveform across the capacitor. And similarly, after getting output voltage and output current, now you have to find out what is the voltage across the diode. So here that voltage across the diode in positive half diode will be in forward bias condition. So up to this you'll be get that diode voltage is 0, and after that you will be get that is the voltage waveform across the diode, which basically follows the exactly similar voltage waveform like sinusoidal voltage wave. Okay, so this is the expressions for current. All of you know that is current in capacitive loads, that is governed by these equations. I is equals to CdV by dt. So this is the equations here we follow, and I output current is C into dVs by dt, where Vs is equals to Vm sin omega t sin omega t. Then after derivative with respect to t, you'll be get that output expressions or current expressions of output current, that is W, not W, omega C Vm cos omega t. Okay, so this is basically the expressions of the output current. And what is the expressions of output voltage? V0 is equals to, all of you know, V is equals to 1 by C I into dt. So this is the standard equations used for finding that output voltage, that is 1 by C I dt. And this is basically equals to entire sinusoidal voltage is basically applied to capacitance, so that is equals to Vm sin omega t. So output voltage is basically follows the input voltage up to omega t 0 to pi by 2. At that point, capacitor is charged to Vm. Voltage across the capacitor remains constant at Vm. So due to that reasons, up to this, basically it follows that input voltage. After that charging the capacitor at maximum voltage, it retains that value throughout the period. Okay. Now, if you sometimes we have to know that what is the output voltage across the diode. So for that purpose, omega t equals to 0 to pi, diode conducts and the voltage across the diode is 0. At T equals to greater than pi by 2 diode voltage is basically you can get that what is the voltage across the diode after this period, that is voltage across the diode. This point potential is because diode is in off condition. This point potential is Vs and this point potential is V0. So voltage across the diode is basically governed by this equation Vs minus V0, and Vs all of you know Vm sin omega t, and V0 maximum value is Vm. So this is the expressions of the Vm sin omega t minus 1 for this period. So in this period, if you want to find out Vd average, that is 1 by 2 pi 0 to 2 pi Vm sin omega t minus 1. And after taking integrations, you will be get in this period the average output voltage across the diode is Vm, and RMS output voltage across the diode is basically equals to, that is the same similar equations you have to use. That is the standard formula 1 by 2 pi 0 to 2 pi. This is the expressions of the diode voltage, that is Vm sin omega t minus 1 square d omega t, which is equals to root 3 by 2 into Vm. Okay. So in this way, you have to find out voltage across the diode. So up to this discussions, if you have any confusion. বলো। তোমাদের যদি কোনো কনফিউশন থাকে আপ টু দিস ডিসকাশন,